Number 33 on page 215 asks us to find the zeros and give the linear factorization for a fourth degree polynomial, which we have not done yet. And that polynomial is x to the fourth minus 3x squared minus x squared plus 6x minus 6. Now we're going to do this one very much like we've done the other ones. The only difference is it's fourth degree now, and we are also going to have complex zeros. So here's how this is going to go. We're going to start out with the fact that we know one of the zeros is 1 plus I. So we're going to use synthetic division to divide out that zero, and then we'll go from there. So if I use 1 plus I in synthetic division, I'm going to have 1, negative 2, negative 1, 6, and negative 6. So I'm going to bring the 1 down, multiply. Now these look kind of cumbersome, but they do work out pretty nicely when you go to work with them. Like when I multiply 1 plus I times negative 1 plus I end up with a negative 2 here. So that doesn't make it too bad. And now I'm going to distribute negative 3 with 1 plus I. So I get negative 3 minus 3i. And when I subtract those, I get 3 minus 3i. And again, when I multiply 1 plus I times 3 minus 3i, it simplifies to positive 6. So I can see that it definitely is a 0. So from there, what I'm going to do with this, because I have complex coefficients right now, is since we know 1 plus I is a 0, its conjugate, 1 minus I, is also a 0. So I'm just going to bring those numbers down and perform synthetic division on my result from the last problem, and I can go from there then. So bring the 1 down, multiply, I get 1 minus I, and as you can see, this becomes 0. It's not too bad. And then when I multiply those together, I get 0. Then I have a negative 3. And I have just the opposite of what's in my last column, as I would expect for a remainder of 0. So here is the linear factorization of my polynomial. So I have f of x is going to equal my two factors. So I have x minus 1 plus I. Then I have x minus 1 minus I. And then I have to write this one down here. And then I have my result from the last synthetic division, which is going to be x squared minus 3. So there's my linear factorization. That's part of my answer. My other answer is going to be, I want the zeros. So I have two of them, 1 plus I, 1 minus I. And my last zero I'm going to get by setting x squared minus 3 equal to 0 and solving. And I get that the other two zeros are plus or minus the square root of 3.